it's all about how you look at it. Integrals, truthfully, are anti-derivatives, right? They're the opposite of taking the derivative. When you look at an integral, there are usually different parts to it. As you look at this first integral, and I'm going to kind of cover these up here with my hands, although online you get the privy. Everybody else, here you're looking at this question, and what I want you to look at in this first question here is that there is an e to the x squared and there's a 2x as part of this. In each of these integrals, there is always going to be one function that stands out, okay? It just is the stronger function. Now, there is a more mathematical way of teaching you to do this, but I find that this theoretical way is a little bit easier to handle, believe it or not. If you're looking at 2x and you're looking a to the x squared, you basically are saying which one is a stronger function, which is the one that's kind of the boss of the whole process. And if that one's the boss, then where would this have come from? And in this case, e to the x, and in every case, e to the x is always the boss, okay? Always the boss. You remember that with limits? E to the x always wins. He's the strongest function. Exponentials wins. Do you remember that? As you're looking at this function, the same kind of general idea works. E to the x squared is the boss. So in thinking that an integral is an antiderivative, where would the 2x have come from? It would have been the derivative of x squared. Do you follow what I'm saying? Now, that being said, what you're looking at then is saying, okay, what's the integral? And you can cover up, so you can online, you cover up everything but that e to the x squared mentally and say, what's the integral of e to the x squared? And my hope is you're like, well, that's an easy one because integral of e to the x is e to the x, right? And so let's just see if this works. The idea is that if that's the integral, that's my guess, then when I take its derivative, I should get this as the answer. Let me show you what I mean. Let's do the derivative of this. The derivative would be e to the x squared times, what's the derivative of the x squared? And is that the same thing? Yes. Let's look at the next one. The next one you see in front of you has to deal with sine and cosine. And it says 4 sine cubed of x cosine. You're like, oh, which one's stronger? The one that has the power is the boss. That's just the rule. Do you have a guess for it, Ryan? Awesome. Hold on to that thought. The idea is that you're going to look at just one of the functions. All right, so can you tell me your thought process, Ryan, as you're going through it? Okay. So your guess is sine to the 4th x. Here's what I want everyone else to think about. I just told you the one with the power, he's the boss. That's the one that's going to take over. The cosine, where would that have come from? The derivative of sine. Do you see how important it is that you know your derivatives? Because once you recognize, oh, that cosine, that's where it came from, we can ignore it and just forget about it. Where did the 4 come from? If you think about the derivative with your power rules, the 4 would have been up in the power. It would have dropped down in front, right? And we go down by 1. You see what I'm saying? This is our approach. Let's do another one. Well, yeah. Let's just check it if you want to make sure. To check, here's my little check. The derivative of this would be 4 sine cubed x times the derivative of sine. And you look and you're like, same. You're done. This is my answer. The integral of that function is sine to the 4th of x. Here we go. It should, yes. I'm just not dwelling on that, but yes, you're right. It should say plus c. Okay, let's try the next one. I want you to look at this next one. The next one says sine cubed of x, and it says times cosine x. So, which one, Desi, do you think is the boss? Why? Because it has the power. Sine cubed of x is the boss because he's got the power. So that means that this is the one that I'm really going to focus on. I'm going to kind of ignore cosine. Where would cosine have come from, Rebecca? It would have come from the sine. So we're going to do its integral, right? So let's think of the integral in terms of powers. This means that I would do sine to the 4th x, right? Now, Why, Ryan? You really did divide it. When we do the integral involving a power, remember what you do. Your integrals, let's not forget your integral rule. We go up a power and you divide by the new exponent. Yes? The reason why up here it didn't matter was because there was a 4. So when you do 4 divided by, because this went up to 4, and you divided by that 4, it divided out. So this answer, you are correct, is 1/4. Let's just check to make sure it's correct. And for a while, some of you are going to have to do this. You're going to have to just check off to the side and be like, okay, the derivative of sine to the 4th, that would be 4 sine cubed x times cosine x, but we had that 1/4 out in front, so those guys cancel. Sine cubed x, cosine x. Yay! I'm correct. Do you see what I'm saying? So some of this will be, we're going to take a guess, and then we're going to check and make adjustments if we need to. Let's try another one. All right, Abby, I want you to take a guess. Which one is the stronger function here? We've got the integral of x, e to the x squared, which is the boss. E to the x squared. E to the x is always going to be the boss. So I want us to take a guess. Or rather, let's think educationally about this. Integral of e to the x is e to the x. So integral of e to the x squared is e to the x squared. Now, when I look at this, though, I notice there's just an x in front of it. Where would that x have come from? Okay, but the derivative up here was 2x, right? So we would have to compensate for the fact that there isn't a 2 there. Are you following this? So we have e to the x squared. Well, if you want to, off to the side, let's just check this. Okay, we got e to the x squared. Great, times 2x. Oh, but we got that 1/2. That cancels out with that 2. Yes, it worked. Are you with me? The 1/2 is compensating for the fact that this should say 2x. But it doesn't. And so it had to have divided out when they did the derivative. Make sense? Well, we just wrote it in front here. Okay, are we good? I don't know if you'll be able to hear your questions on here, so I apologize. I should be passing this around. But... All right, do you have a question, or you just want to do the next one? Well, I know. You're just excited, aren't you, Ryan? I love the enthusiasm. Okay, the thing about this that I want you to recognize is what happens with natural log questions, okay? And so, Ryan, go ahead and what's the derivative of natural log of x squared minus 5? 1 over x squared minus 5 times 2x. Okay. All right, is everybody okay? Now, when you look down here, and let's just rewrite this so that we can... Okay. When you look down here at this lovely thing, there are some things that I want you to notice as you're looking at integrals that are written as fractions, okay? And this is just a helpful little hint. So you see the integral sign, and you see a fraction. Bring, bring, bring. First thing, if it can simplify, simplify. Remember the ones you could factor? Do you remember those ones where you would factor them out? Stay with that still, okay? But if not, and do you notice this cannot factor? Nothing can simplify this. You need to look and say, okay, is this a function down here? Then it's probably involving a natural log. That's your clue. And that is your only clue, by the way. It's it. If it doesn't simplify, then it must deal with natural log. And so you're thinking to yourself, okay, that means I've got the natural log of x squared minus 5. Are you with me? You see how this is working? And so what you have in this particular question, let's just check to make sure that we have everything we needed. That would be 1 over, right? And we would, oh, yeah, x squared, and then we'd get the 2x, and oh, voila, there it is. And so it is, this is my final answer. This would be the integral of 2x over x squared minus 5. The kicker about this is being very comfortable with your derivatives. Now, here's the truth of it all. In the CLEP exam, it's a multiple choice test, right? If you stink at these, worst comes to worst, you're going to do 4 different derivatives with the choices and see which one's going to give you the answer that you have in the question. Let me say that again. If you can't do this, for you just don't visualize, you can't pick out the stronger function, then your option is to go through each of the choices and do their derivatives. It obviously takes you a lot longer, doesn't it? Wouldn't it be easier if you could come up with some kind of educated guess and eliminate some of the choices? Yes. And that's the goal, okay? That we can eliminate some of the choices, we can come up with a better guess, okay? Now there's 5 minutes left in class here, and so I'm going to stop this video because nobody really